Hello, everyone, and welcome to a new episode of Kodsnack. As you can imagine, this will be a bit different episode since I'm already talking in another language than you usually used to hear me in. But it's because we have a guest today that his Swedish is not that good, and our Spanish is not that good. So we're going to try to come together in English instead and have this discussion. But first, I want to introduce you to my co-hosts, Kristoffer and Fredrik. Welcome.
Hello, thank you.
Hi. So I think today is going to be a very good show. For the last couple of months, it's been like 6 months, I think. I've been working on a project at Plex for building basically all the dependencies needed to build the media server itself. It's a lot of dependencies. It's 75 the last time I looked. So there is a lot of code there that needs to be written and built. And when we started that project, I was 100% convinced that I didn't want to write that code myself anymore. Basically, the old system is an big old Python script that I wrote at some point. So I was looking around for alternatives, and I stumbled across something called Conan.io. And today we are very happy to have with us Diego from Conan. Welcome, Diego.
Thanks very much, Tobias.
Yeah. So this is funny because me and Diego has been working together for 5-6 months or something like that. And this is the first time we actually talk to each other by voice.
Exotic.
Yeah, it's funny. So welcome to the program. Can you introduce yourself and what you do at Conan and what a brief overlook of what Conan is?
Yeah, sure. So actually, I was a professor and as a researcher in robotics, and I was the whole day coding in C++. So this was kind of my own pain, and there was nothing. So one of the things, I quit academia, and then I started to work on this problem, and then we came up with Conan. And yeah, we have been working in Conan for a while, and now we are part of JFrog. So I'm a senior software engineer at JFrog. And working Conan full time, so that's great because Conan seems that it is working. So about Conan is the missing package manager that C and C++ languages have been looking for a while. Actually, it is our second iteration at this problem because when I quit academia, we tried with another startup that it tried to build a dependency manager for C++ and we failed. But when all the lessons we learned from the experience, then we decided to try again. So we were focusing on a couple of things for this new thing called Conan that we built from scratch. One thing would be it managed binaries because as you said, Tobias, okay, so you have 75 dependencies.
Yeah, we do.
This is very typical. I mean, C and C++ projects, they have millions of lines of code. It's not like a JavaScript project, so they are really huge. So you cannot build from sources everywhere because your dependency manager builds from sources. There's no way. So it is absolutely necessary that a package manager builds binaries and store binaries, and you can reuse binaries. So this is one of the main things that Conan would do. And also another thing is it has to be because C and C++ projects, they won't depend on external infrastructure so much as other packages, other languages. Probably other languages, they are fine with using Pypi or NPM registry, but C and C++ are critical projects. We have defense projects, we have embedded projects, industrial, and those industries, they are not willing to have their servers outside of the company. So we really work hard on having fully decentralized thing. Something like Git, that you can just own your own server and store your private packages, everything on premises. So this is one of the things that also we focus on Conan. And the last one would be multi-platform support and multi-build system support, because it is quite easy. I mean, if you design a new build system or just apply for a Nix platform, let's say Linux platform, it is more easy, but you cannot just ignore more than 50% of the developers in the world, based on the Stack Overflow survey, they are working on Windows. And you probably most of the C++ projects, they are working in Windows, all the desktop applications. and things like that. So a package manager has to have full support for the Windows platform. And also, you have tons of legacy projects with all build tools, and even companies, they have their own build systems. It is so if you're developing a package manager, you have to be able to copy in any operating system and with any build system. And it's something that Conan can actually do. So this would be more or less the main things that Conan as a package manager try to solve and try to address.
So is it fair to call Conan like you hope that Conan becomes for C and C++ what NPM has become for JavaScript? Is that accurate, or is it? Do you see that as a totally different project?
No, it's very similar. I would say that it would be the equivalent to Maven for Java. Yeah.
So your former project was biicode, right?
Yeah, that's true.
And what would be the biggest differences between Conan and biicode from your perspective?
Well, huge differences. Actually, nothing to do. Biicode, actually, we call it biicode. So biicode was doing like a dependency management for every language with two important things. It was doing like file-based dependency management, so you wouldn't build packages, but biicode like scrap the source code, get the includes or the directives requesting other files. It will use that information to build a dependency graph over files, and it will deduce automatically build the scripts for you from that graph. So it was very automatic. It was centralized, so it always depended on a central server in the cloud to operate. So that was a major blocker for many users. So it was a very academic and opinionated project. It was interesting because it was like it featured a powerful SAT solver on the server, because I used to work in artificial intelligence, and together with a former colleague at university, we have like the best maximum click solver in the world, like the fastest one.
Oh wow.
So it is like a very state-of-the-art, and so we deployed a solution in our servers, and it was never used. So it was like the perfect academic solution, but it was not pragmatic at all. So users, they were not requesting that. They didn't need such features, so they wanted a different thing. So it was a beautiful project with nice ideas, cool ideas. But as I said, it was a bit academic and opinionated. So actually, Conan is very much the opposite of biicode. Like managing binaries that biicode didn't do, because it was already building from sources all the time, and it was centralized to biicode. And Conan is also the opposite. It is decentralized, and biicode was always using the cmake build system. And now Conan can manage any build system. So as you can see, we just build the opposite thing.
Yeah. So it's fair to say that Conan is a less ambitious project, maybe, than biicode was.
Yeah, absolutely. biicode was trying to target the whole developers market, because initially it tried to market all the programming languages. So and now Conan is just trying to solve in a very pragmatic way just the C and C++ problem, that it turns to be a huge problem also, but it is not as big as just trying to change the whole programming paradigm in the world.
Right.
So yeah. So the ambition is very, very different in the sense. Yeah.
Yeah, I have to say, from my perspective, Conan does a lot of things right that I think a lot of other package managers don't. So one example is the decentralization. So from my perspective, as someone who works on a Linux distribution, I wish that all package managers were focusing on that, because that is really important for us, since we need to. Since we're shipping all the sources and all of the binaries that we build, we need to be able to track the history and the state of all of that stuff. And relying on outside build service, it just doesn't work. And in the same way, I think something that we are learning more and more is that relying on a SAT solver and trying to do dependency resolution automatically is probably not the best way to build a system. It's not the way to get things really reliable. You really want to explicitly say that this version of the software was built with exactly these versions of its dependencies, and be able to track that exactly.
Absolutely agree. Actually, you know that Conan didn't get version ranges till a very recent release, because so from the very beginning in Conan, you always have to define exact versions, like pinit versions all the way up and down. So it's true that many users, they were, okay, I want version ranges, so finally we implement them. We still think that it is much better to define perfectly. And what we are seeing in companies using Conan is that dependencies in C and C+ projects, they are very fixed. So you are depending on boost 160 or 159, and you don't change it. You don't define, okay, I want a boost from 150 to 160. That doesn't happen.
No.
So your dependencies are always very, very fixed, very pinned to the... And I think it's a much sane process that just, okay, depending on anything, on NPM, external infrastructure, on any versions with version ranges, that it will change over time, all the time.
Yeah.
Right, we have all seen like the horror stories that comes from NPM and like packages being removed and being in a centralized place being, you know, censored basically and stuff like that as well. So I think that was definitely an important part from my perspective when we selected the system for Plex, because as I said, like I think this is the situation in many companies today when they are using dependencies are that they have some kind of own system to roll out the dependencies, right? Either they do what we did before, have a handwritten system in whatever language they like. Usually it's a bash script or something like that builds all the dependencies. Or they just copy and paste the source code into the whole project. So that, you know, the one build system builds everything. But like that works when you have one or two dependencies, but when you have 70 dependencies and one of them are things like boost and stuff like that takes quite a bit of time to actually build, that is not scalable. So one thing that we were looking into for sure was a system where we could have full control over it. It was very important to us because we are also working in JavaScript projects, right? And our JavaScript project is using NPM like everything else, and we know what kind of pain they go through to make sure that system is working correctly. And one of the big differences between Conan and the system we had before is that before we checked out everything from Git, like basically the master branch, or we had a deploy branch or something like that called, and it built it, but there was no traceability. So one of the things that we really wanted to look into was to have traceability in terms of being able to see which dependency was actually used to build this version of the media server. So all those parts I think are very important as you highlight them, and it's been a deciding factor from our perspective to choose that. Do you think like most other languages today have a package manager that is more or less standard? Do you have a feeling on why we haven't seen a standard project like package manager for C and C++ yet?
Well, that's a very good question. Actually, I think the first thing is the C and C++ package management would be the most difficult one, because other languages, they have just one build system. But in C and C++, if you join together that you have different architectures, operating systems, compilers, and all of them generate different binaries that are incompatible, and then you also have to deal with very different build systems. So this is a more difficult problem that if you just try to package like an interpreted languages like Python, it would be fairly easy to package that. Not to say that Pip or Pypi is an amazing project, but it is easier. It is an easier problem. And also Maven, for example, for Java, that is a huge tool, very powerful, and all that. It has the advantage that is just build once and run everywhere paradigm of Java. So this is also easier because it's not only the package manager, it's the package manager and the build system together. If you own the build system, it is much easier to write a package manager. If you don't, it is much more difficult. So, and also, an important thing is that C and C++ has suffered like a different history. And several years ago, before C++ 11, it was starting to consider like dead, or it is going down, really going down. But right now, with C++ 11 and the newest standards, it is again growing, and it is getting more importance because energy and performance and embedded systems and all that stuff. C and C++ language is still the best option for them. So it is getting more important every day, and software is growing in complexity, more people developing. So it's the moment that right now we need these dev tools like a package manager for C, C++. In the past, it was not such a big issue because you had less dependencies, you had less C++, but now it is really necessary to improve the processes and to go faster and to release faster. So you need a package manager for that. Now, in the past, you could live without it.
I was curious to ask if you guys are involved in the standardization process for adding modules to C++. Now that C++ 11 and 14 and 17, and there's kind of this movement in C++ again, they've been trying to standardize on a module system, but it hasn't really happened. And I was curious kind of what your thoughts are about that, and also if you're involved in some way.
Yeah, so the module initiative for the standard, it is an amazing one. I think that most of the C++ community would agree that modules would be great. Yeah. But it is also a very difficult problem because all the amount of legacy code using macros and preprocessor tricks would make the transition would be difficult. So we will not see modules in C++ 11. There are several proposals in Clang and also Visual Studio, but I think we will have to wait until 20. So we are not involved in the standardization process of that. Actually, I still think this is an orthogonal problem. Package management and modules are different things, because modules are more like for the build system, completely removing away the preprocessor step and using like a different build approach with the interface to the modules and things like that. So it would boost performance in builds. So builds will be much faster, and modularity and everything will be improved. But still, you need a package manager to manage, because you will have libraries, and libraries will have modules, and they will have libraries defined by modules. But you will have them. You will have them anyway. So there is still a way. You will still need a tool to manage those modules. We did a trial with Conan with Visual Studio modules, and it can be done. I mean, we just call in the Visual Studio compiler in the command line with Conan, and you can create packages with modules, with Visual Studio modules. So I'd say we don't pretend to get into that standardization problem, because I'm really looking forward for the modules get standardized. But in reality, I think that we will have to wait many years. So until they are mainstream, probably no less than 5 years. And in 5 years, we have tons of C and C++ code to do. So Conan has to be used right now for legacy, and it will be ready, and it will be very useful for packages built with modules, with C++ modules. But yeah, that we.
Yeah, but it's also true that when it comes to C and C++ compared to other languages, it's interesting that somehow as an accident of history, maybe you could say, these concepts that are orthogonal, as you say, have become split up. Whereas in the case of NPM, it's one single program that handles modules and builds the packages and also is the package manager. So it's all intermingled. Whereas with Conan, you can kind of focus on just the package management part. And there are other tools, like you call out to build systems and you don't worry about the exact binary format all the way and so on. So maybe that's also kind of an opportunity to do things in a cleaner and more modularized way than in some of the other languages that have everything in a single tool.
Yeah, the thing is that also there is very practical. I mean, for example, Rust, you have the cargo, and cargo is managing everything. It's managing the dependency management, and it's managing also the build. And the experience for the developer is just great. So the couple thing and having a orthogonal package manager for Rust and then a build system for Rust, probably it's not necessary. I mean, working together, if you have just the cargo build system and the cargo package management system, it works perfectly. So it is true that we really believe that Conan is powerful. For example, we have tried to do Golang package management, and you can do it with Conan. We have also a proof of concept for Python, so you can manage Python packages with Conan too. And of course, for example, if you have any other compiled language, let's say Fortran, you can perfectly create packages for Fortran with Conan because it's very generic. That's true, but the thing is that we made that scene in biicode. It's almost impossible to get into those markets. Yeah. Even if you have a tool that is amazing and can work in a very generic and orthogonal way to that, the community won't move. For example, in Python, you have pip and the Python package index, and it works great. It works great until you get to native extensions.
Right. Let me tell you about that.
Yeah. So for that, for example, you will have like the Conda package manager for Python, that it is more powerful and it is able to deal with native extensions. So, for example, for scientific computation, like NumPy and NumPy, all that stuff, it would be easier to install them with Conda than with pip. But still, Conda is not getting like the majority of the community of Python developers. They are not using Conda; they are using pip because it's good enough. Even if you have a better, and from the technical point of view, you have a better alternative like Conda, the community won't move if the tool that they use is good enough for them. So it's not enough to have a better tool, but also it has to match like the expectation of the community and the real pains of the community. If the 90% of the community doesn't have that pain, they're not going to move. Things are going to be still the same. So it's not. Software engineering is not only about technology. So probably the most important thing is the people and the human relations. So still, if you have a tool that it could be better, if it is not like 10 times better for the real end user solving a point, they will not move to it. So in that sense, Conan could manage many languages, but we are not trying to target those markets because it will not happen.
Right, but at the same time, it's also a strength when you get into the system. So, for example, on my side, we actually use Conan, and we started to look at it as the way to distribute our C and C++ dependencies, right? But we are today, with the setup I've done, we are also distributing resources via Conan, like plain. We have like a font package that is used for subtitles, for example, and that is distributed by Conan because when the designers and the guys who are working on the fonts and how it looks, like they can just package it up, like push it to a Git repository, and we get that into the next server. So it's been a big strength from our side of view that Conan is not just limited to just doing C and C++. Like when you are using that system for your main purpose, and also can use it for some additional things like resources and Python packages. We are packaging some Python dependencies with Conan as well. So I wouldn't. I agree. We would probably, if you're starting a Python project from scratch and you want to have a way to distribute Python packages, you're probably not going to choose Conan for that. But if you're coming it from the other way, like we're using this to package our C++ dependencies, and it can also do all our Python dependencies. That is a plus in my book, at least.
Sure. That sounds great. So you are using Conan also for resource management?
Yes, we are.
Oh, that's great. That's great. Yeah. When we designed it, we just define a stage, the source stage, the build stage, the package stage are all very general, because we wanted precisely to be hackable, and that people could do the things, because C and C++ developers and projects are widely different. And people will have widely different workflows for the same problem. Let's say they have to develop a project, an application to release and everything, and the way they approach the problem will be very different from one developer to another one. So you have to provide the general framework, general enough so people can do anything they want. So it's great to know that you are also managing resources with Conan.
Right. So because that is definitely one of the problems I had when I wrote my own dependency system 5 years ago, was just the fact that there are so many different build systems for C and C++ with very varying quality. So, for example, especially when you go into cross-compiling, right? That is a huge problem. I can tell you that there is a lot of build systems that were never meant to be used in a cross-compiling scenario. Like all the big ones are, of course, working fine. Like all the Automake tools and whatever, they can cross-compile on Linux perfectly fine. Autotools is a huge pain in the ass on Windows, but for the Unix platforms, they work fine. And cmake as well, it works fine to cross-compile stuff with cmake. But then you have all the different small stuff, like the Boost build system is probably my favorite to hate on, because that system is so inscrutable that I don't know if the developers themselves understand how it works. And then you have people who are just writing straight up make files that have never been used in a cross-compiling scenario. And the power of Conan here has been to be able to actually write working package recipes for all of them, right? So that has been a huge plus in my book, that I've been able to, instead of having, because I think you when you go into a problem like this, you start to focus on a couple of dependencies that are using the standard systems. It's kind of easy to write a system that can package up auto tools scripts or autotool packages or cmake packages. That is easier compared to some of them. And one thing that was really key for us to choosing Conan is also how you can output information that can be used by different system. So can you talk a bit about that? So when you depend on zlib, for example, you can actually output via your generators a lot of different information. So can you talk a bit about how that came to be and why you had such a pluggable system on that end? Because usually that's you can have a pluggable system for building the things but not consuming them. Yeah.
So actually, how do you solve any problem in software engineering?
Trial and error.
You try and fail.
No, with another layer of indirection.
Right.
So that would be, So when we started to work with Conan, what we did, we did we started with the problem. So we knew that, for example, many people were using Boost. Mm-hmm. And Boost it had a different build system. So, and you are not going to change that. Pretend that you are going to create a new tool, and the Boost community is going to, let's use Conan, let's forget about our build system. That's not going to happen. So we did the other way around. So we knew that we have like a boost build system, for example, and we have consumers that they are going to use that from Visual Studio from cmake. So then obviously what you need is a level of indirection. So what we did here is, okay, so we built the model. It's the Conan model for dependencies and C++ information. In that model, you can encode all the typical information like the include paths, library names, CPP flags, C flags, precursor definitions, and things like that. So when you build a package, then that package will define the information for consumers in a package info way, in a package info method, in the recipe. So it will declare that. And it will be it will translate the original package information, it will translate to the Conan model. Okay, and then it will be stored in the dependency graph. And then when a consumer wants to use that dependency, that information will be translated back to the build system that the consumer is using. So if the consumer is using cmake, what Conan does via the generators, okay, I'm going to write a cmake file for you. And in this cmake file, there will be different things. There will be cmake variables with all the include paths. It will be cmake variables with the library names and so on. So you can just include that file in your cmake build in the consumer side and just use it. It's very simple. And the good way about it, when you introduce a layer of indirection, the good way is that it is very extensible. So if you want to target a new build system, then you can do it. You already have the model in Python, and all you have to do is write your own generator. The generator will take a Python model. It will be basically some dictionaries, and you will output a file with the syntax you want. For example, for qmake, it will generate a qmake file with the include paths and the library names and so on, and it can be used in qmake. And a beautiful thing about this is not only for build system. For example, we were contributed with generator for Youcompleteme. For Vim users, you can use the Youcompleteme, and the Youcompleteme plugin, it needs the include path, the include folders for headers to be able to complete. So you can write a generator that will take the include paths of your dependencies, generate a Youcompleteme file, and then Vim users will have the autocomplete for their dependencies. And it's a beautiful concept you can implement with generators.
Yeah, and one thing that, because this was something that confused me a lot when I was starting to work on Conan, because most of the build systems you use for C and C++, it's actually the build system on the consumer side that is responsible of finding a dependency. So, in the old way we were working in the Plex media server, we had this huge cmake file that tried to find all our dependencies, because the dependencies were not all going to be able to be found with pkg-config. Some were found by just trying to compile and some are found by scanning like a directory for a specific header file and so on. So there's a lot of code that has to go and to manage also how you include that dependency into the media server, for example, in this case. And Conan kind of flips that on your head, like the library itself defines how to use the library. So it's kind of similar to what a pkg-config file does, but it does it in a much more structured way, I found it. So it's not up to the client to actually find the library. It's up to Conan to provide you with all that information for you. So you just have to include that file into your build system, and everything is found, and you don't have to care about which include path it is anymore, and so on.
Yeah, absolutely. I mean, most of the ideas of Conan, they are not new. I mean, you have brew, for example, for OS X, that is beautiful. In this case, the idea is the same as the PC files in Linux. So it will be the dependency to define a PC file that the consumers with pkg-config, they can get the information there. But you definitely don't want the consumers to be able to figure out themselves. So from cmake, for example, I guess you are talking about cmake. cmake has very nice things, like being able to generate projects for different Visual Studio systems and things like that. It has a terrible syntax, I think we all hate the syntax of cmake. It's very.
I think everyone who has worked with cmake has a very strong opinion about this cmake language.
Yeah, as you already said, that is a pain in the ass. Absolutely. And especially, I think the find package feature of cmake is just an abuse of the system. So they had a build system, and they had to deal with the fact that they didn't have a package manager.
Right.
So they tried to figure out something, and it's just a patch. It's just a bad solution to a problem with the cmake approach. So I really hate find packages in cmake. So I think the other way, like the PC files, is the wood one, and it's the one we use for Conan.
Right, and the problem with PC files is that they are very centric to the Unix world, right? There is no good way to use a PC file on Windows, for example. So that has also been kind of a problem with that approach. I think it's time to switch discussion a bit here. I thought that since we had you on, Kristoffer has actually done a talk on package managers. So I think it would be interesting to kind of talk a bit about his point of view as from like a Linux distribution maintainer. So Kristoffer, I think you have some thoughts about language-specific package managers and their relation to like a distribution. Could you kind of lay out a shortened version of your longer talk there? or your thoughts on the matter, at least. Yeah.
So, I mean, the problem that I'm seeing is that I'm coming from the distribution side, where we have to build software of all kinds, including Ruby on Rails applications, including C libraries, including C++ and Go and JavaScript, all of these things. And what I've seen kind of from that perspective is that building C packages for C and C++ is actually not that hard. Like integrating C and C++ projects is usually not a big problem in something like apt or RPM packages or deb packages, things like that. Because in general, C and C++ projects don't have a package manager of their own already. Until now. But so kind of historically they have relied on, for distribution, at least on the Linux world, they've relied on the distributions to handle that part. So it kind of naturally adapted to that. So for example, using the autotools, it's almost seamless if you're using RPM, and you can see how those tools kind of were built together or built, in a sense, thinking of each other. But when you get something like npm and trying to manage dependencies of JavaScript applications as RPM packages, that just becomes completely impossible, because there's just so many packages, they depend on each other in such a strange way. All the tools rely on going out on the internet and just downloading things as they want. And all these things create a lot of problems for that kind of distribution model. But kind of what I felt as I was thinking about this and trying to come up with a solution is that I think kind of the distribution model for package management is going to have to change drastically to adapt to dealing with this, because as you're getting package managers for C and C++ as well, or maybe, I don't know what the future looks like. Maybe something like Rust is going to take over a lot of the market for C++, and Rust already has cargo. So eventually we're going to end up in a situation where every language, where developers working in a specific language already have their own tools for managing packages for that language. And the question then is, how do you compose all of that into a single system? So it's a tricky problem that I don't have a good answer for. I was wondering if you've heard of projects like Nix or Nixos that try to do reproducible builds where you can build something and track exactly all the dependencies and so on. Because I can see at least I think I see some influence in that kind of way of thinking of reproducible builds and tracking dependencies using the hash of the dependency and so on in Conan as well. But yeah, it would be interesting to get your perspective on that.
Yeah, so I think Nix is an amazing project, okay, and it works great for Nixos, the operating system. But for example, there is a couple of things with it. One thing would be assuming that the packages can have a single hash. So
Right.
that is true if you are working in packages for just that distribution. For example, I would put it as an example. We have dependencies in Conan that they change dependencies between the operating systems, because if you're in Linux, for example, you will depend on electric fence to check for memory and things like that. And that dependency just doesn't exist with in Windows.
Yeah.
So you have a different dependency graph if you change operating system. So there's no way that you can model that with a single hash. So that's a major problem for Nix, in my opinion. And also that it doesn't provide like first-class support for Windows. As I said, like more than half of the market would be Windows application. So Nix is great, but if you don't do something that yeah, I think that still we don't know the future, as you said, and something has to change, because okay, so we have language package managers. That's great. They still don't fit very well with distribution to final applications. But
Yeah.
we also have like all the containers trends going right now. So it seems that we are going to develop applications into containers and probably don't use that much those system package managers. But in any case, the full DevOps world has to change. There's no way that developers we are creating like a Hello World application and we want to distribute it to the world, and actually it's a nightmare. It's a nightmare. You cannot do it. And the worst thing for me is that we know how to automate all the parts in all the operating systems, but there is still not a whole approach to the problem, since you write the code till you deploy to final users' applications for many different systems. So, in my opinion, this will change in the next decade, or probably a bit more. The programming paradigm will probably change, and of course we don't know how it will look like. Probably approaches like Nix are giving like ideas and good basis, and okay, that now the functional approach is everywhere, is trendy. Let's apply it to package management. We will learn things.
Yeah.
And probably we'll end like getting good things from the Nix functional approach, also from the old approach of let's say Conan, that is equivalent of the object-oriented programming package manager, let's say in that way. But both techniques have good ways, because Conan is able to work in Windows, is able to catch binaries, is able to deal with any build system, and Nix cannot do it even if it is perfect and from the functional point of view. So I think in the next years we will learn how to take the best of each world and come up with a solution, a DevOps solution that it will be more big. But who knows?
Yeah. I think maybe that's one of the things too, is that everyone tries to look for a silver bullet, the one solution that's going to solve everything. And the reality is that when you're actually trying to build something, you have to build for all of the platforms that are out there today. And it's not really good enough to say like, well, let's build a whole new system that's beautiful, in all the parts. Well, then you look at, you also have users on Windows and on macOS, and they're not going to change anytime soon. So you have to be able to adapt to that. So yeah, but finding the right solution that works everywhere and makes development easy, but also makes distribution easy is an interesting problem. I think you're right that the DevOps world as it is now needs to change, because right now it's very focused on the developer part and not so much on the ops part, which includes maintenance and distribution. So putting everything in a container and putting it on a server and running it, that's great. But then keeping track of what's in the container and keeping track of security patches and keeping track of how to update it and so on, that's a whole other problem that's not really solved today. But I think, projects like Conan actually show kind of ways forward in that sense. So it's interesting to see kind of the solutions that you're finding, because I think since you're working from an older language or older languages, you're also having to solve problems more pragmatically than package manager for new languages that can influence the design of the language itself to adapt to the needs, so to speak.
Yeah, I think especially that it will be amazing, and I think it's a very interesting challenge. Okay, so we have the old legacy code, C code, and we also have the trend of the Internet of Things, that we will have devices running most likely C and C++ code, and those things, they have to be updated. And okay, so now as a developer, you can build your packages in Conan, you can build mainly for let's say desktop or server applications, but what happens to, how are you going to distribute your patches? How are you going to update the devices? What is going to happen there? So I think the amazing thing is that we will learn and we will have to solve these problems in the next years. So I'm really looking forward to this challenge.
Yeah. So I have a kind of a general question about Conan. Is what kind of adoption are you seeing of Conan? Where it's always interesting when you create a project and you have something in mind. You said that you come from the academic background. Was that your original market for the tool that Conan is, and has it seen adoption there, or has it been surprising to see that it's actually getting used over here instead?
Well, there are two things. The adoption of Conan is going just great. I mean, the same as Tobias has done in Plex and using Conan for managing dependencies, it is happening all around the globe. And every day with news from a different company that they are using Conan to develop. And this is just great. I mean, right now we're just having a problem of scaling and just keeping up to the issues and supporting users and things like that is becoming a problem. But of course, that's good news. Good news. Very good news. So we are really happy because it seems that we have something. We have something, and it is really getting traction. So that would be one thing. And the other thing is I've seen adoption in my original community. I came from robotics, mainly in robotics and artificial intelligence, and also academia. So there's still I'm still not aware of any success stories. There in robotics, they are using like the robot operating system. It's called ROS. It's cmake based, and they have like kind of dependency management. They have like kind of packages for that robot operating system. So right now, going into that specific market is not going to be that easy in the short term. But I think we will be. I mean, we have been talking with some of them, and they have the same problem because they want to release like ROS for Windows. And just building the ROS system for Windows is difficult. So probably Conan could be a solution for them. So we'll see. Yeah, but so far, no, I'm not aware of robotics people using Conan.
No, but there are a lot of other companies using Conan, right? So that's what you're saying, that there seems to be something that it actually speaks to people that are using C++. And I know we discussed this before, but I know you are of the feeling also that one of the reasons it's been hard for a C++ package manager is also because if we're talking about old developer communities, like the C and C++ are some of the oldest, and they are very set in their ways in some ways as well. It's kind of hard to promote something there as well, not because they don't need it, but because they are already very happy about whatever solution they have. And then there are a lot of us maybe a bit that have lived in other worlds than just C++ that are kind of confused why this trend is going on still with a lot of manual work to get the dependencies figured out and so on.
Yeah, so I think indeed there is a friction. Because you have companies that they have their own projects and they're already huge. Okay, and if you want to deploy a package manager, it's going to be some work, of course. You have to change something. Even if Conan integrates well, you will have to invest time and people to do that. So it depends on the size of your project. If you have like a 10 million lines of code project and you have to keep releasing every month, for example, and things like that, it's not that easy that you will be able to introduce Conan to use it. So, and also, depending on the background, and if the people, they have used other package managers or not, or how many different developer tools they are using, you will see that, of course, there is friction to change workflows. And if you say, okay, so you have to modularize, you have packages. Okay, I want my project with all my dependencies in my Visual Studio project. Mm-hmm. I mean, this is not exactly the way a package manager works. If you have packages, they are isolated and you will work per package. And you will have to test your package and be sure that your package is working and everything. It's not that you can touch in a package and then in another one have do code changes in 4 or 5 different packages and then build the whole project and it will be fast, it will be perfect, and it will be everything automatically. Because if you are the coupling and you are introducing a package manager, you are like really separating things, and you cannot work exactly the same as you used to be. So if you have a pain because your project is huge and it takes forever to compile, you really have to divide. And once you divide, you have to work per package. You cannot do both things; they are opposite. So we have some frictions in that sense. That people don't want to change at all their processes, but they want the advantages of having a package manager that will cache binaries and will do everything for you. Okay, and we talked a lot to people that say it cannot be that way. So in some way we have to also to evangelize towards modern software practices and how to structure a project, how to manage a project. Hey, you cannot have an issue in your Jira tracker or whatever that you need to modify in opposite places of your project. This is a mistake by design. That you have to redesign your project to really separate things. But it's not that easy, of course, to do that software engineering to your projects, to really organize things into packages. So it's kind of a trade-off. It depends how much investment they need to get the advantages of having a package manager.
Right. Yeah, and I mean, that was definitely something that took a long time internally at Plex, is that this is a project that has been going on now for almost half a year, because when you're converting 75 dependencies to a new system, whatever, and especially since we're building for like iOS, Android, Mac, Windows, Linux, and multiple different versions of, Linux ARM architectures, there is a lot of work going on here, right? So these big projects with an already existing infrastructure, there is probably going to be a lot of pushback for like implementing and pulling everything down and trying to get it. And I mean, just now, 6 months later, we are in the QA phase. And I mean, these guys, they are finding issues. And, this is just a process. But we are betting on that this is going to help us in the long run, right? But it's very hard for me to justify this and say that we're going to have 100,000 more customers because we do this. And this is always the problem with working with infrastructure, right? It's never so easy to justify the cost for a big project like this towards someone who is looking at the numbers.
Yeah, absolutely, and that's the reason that many companies still they are working with Subversion instead of moving to Git.
Yeah,
you need to train people, and those numbers they are so clear, so evident to managers to invest in them. So yeah, that's a real issue, but for all developer tools generally.
For sure. And we had the same problem, I know, when one of my first things I did, or actually not really true, but one of the things I did recently as well, a part of this was to switch our build systems to all use cmake, because the media server before was built, we had 4 different build systems to build the same application. We had Visual Studio, we had Xcode, we had cmake, and we had a Java-based something. And one of the reasons we wanted to switch was because it was horrible. It was really hard for the developers. Like if you're the guy sitting and working on Mac all the time and you add a file, you need to pull up like 4 different virtual machines just to be able to add that file to the build systems. It was very time consuming and annoying, to maintain 4 different build systems at the same time. But when we did that, I remember the gnashing of teeth from developer, especially the Windows developer, seems to be a common thread here, is that they were very scared about losing their Visual Studio integration. And it's totally understandable, right? You get very attached to the tool you're using every day to do your work. And it's hard to change a workflow that deeply. Like, no, I can't just add the file into Visual Studio anymore. I need to go into this strange text file with this strange syntax to add the file. So that was definitely, and I don't think I see the same resistance to Conan, because we had so much problem with the old script. That there is a definite pain point for everyone here that we're solving, right? And it's changing the workflow a bit, but it's not as drastic as you need to use cmake instead of Visual Studio, right? So there is definitely some leeway there I've had internally to get this project up and running and working.
Cool. Yeah, I think it's the same in every company that they are adopting Conan. It would be a similar process. I mean, the pain is bigger than the investment they need to do to use Conan, and those are the companies that are onboarding Conan. Some of them they will not, because probably the pain is not as big as the investment they need. But we are see that the balance is many times going towards Conan, so that's great.
Right. Kristoffer, any final thoughts?
Well, so I have one question that I was thinking of earlier. That was, you were saying that the previous project that you made, biicode, had more magic. I think you said something like that. And that Conan is a bit more explicit, I assume. And that's kind of an interesting balance that you have to find between being very magical and everything just works, and being explicit about what you do, because the magic eventually becomes a pain point when you want to figure out what's actually going on. So I was wondering kind of how you found that balance, and if you're happy with where Conan is now, and in that sense.
Yeah. The thing is that magic will always block some user. If you have something that is very automatic and it's not explicit, you will find blockers all the time. So it is not good. Okay, the magic will work in, let's say, 80% of the cases, but if you block like 20% of the cases, it will be a nightmare. So in that sense, we like very much the Python thing, like being explicit rather than implicit. So every time we can make a decision, a design decision, to make something explicit, we try to do so. So yeah, there are some places that you say, okay, I would like this thing to be more automatic into Conan, and we say no. We prefer you to write things, and you will write explicitly what you want. Okay, you have to write more. We know it, but it is fine. So yeah, we in our design we always take that into account, and we prefer much more explicit than implicit or magic. This is our view. Of course, other people would say the different, that we just a magic script that will do everything for them, but that is not real. I mean, that doesn't work in our opinion, of course.
Yeah.
So yeah, I'm opposed to magic. Everything that can be really explicit is much better.
I feel like that's one of the mistakes that a lot of people do when they try to build something like a package manager or a build system, is that they take whatever their make file did before and they wrap that up into a function that calls make. And then you go, oh, it's super easy. It's just one command. But really, they've just hidden all this complexity. And when they try to do something different, it's not going to work at all.
That's what I hate. Like package managers or build systems that they are declarative. They are using a YAML or JSON or XML file. I hate them. Yeah. Because all the time you need something special, and it is not enough to declare, okay, so my URL for my source code will be this, and the system will manage everything. Because at one point you want to change, and okay, I don't want this source code, I want this, or I want to patch my sources, or I want a different origin, or I want to do something different. And if you have just a declarative system, it is going to block you. So I am 200% convinced that you need a script system. You really need full scripting for a package manager.
Yeah, I mean, that is definitely something that, like, when you're using a declarative system, it's really about reducing everything down to the lowest common denominator, right? That is what it becomes. And one of the things that Conan does well, I think, is that you have, within the build function, you have total freedom to do whatever you want to. You're basically only given some tools to do some common things, but if you want to stray outside those tools, there is nothing stopping you, as long as you can contain your build within that Python function that is called build, basically. And that makes it, like, we have some of the scripts that are doing some pretty crazy stuff in the build function, building the same tree twice with different flags and combining the output and stuff like that. So there is definitely some interesting things going on there, and it's made it a lot more flexible in the way that you have to all the freedom you have. But at the same time, there is freedom to shoot yourself in the foot, right? So you have to be careful. It's not a system for people who wants to have the ease of maybe a JavaScript,
but Tobias, you already are using C++. That's the biggest.
This is very true, right?
That's the biggest gun to shoot yourself on the feet. So
this is very true. Like, if you're a C++ programmer, you're very comfortable shooting yourself in the foot. It's one of the things that you do.
Actually, you love.
Exactly.
So my final question: what does the name come from? I mean, I think of Conan the Barbarian, but there's other Conans as well.
It's mostly based on Conan the Barbarian. Actually, it started with C. The C letter is very important. And probably the best thing is that the domain was available. So we were joking about different names and whatever, and everything is already bought. So when we say, hey, Conan, and it was free, the domain, and we didn't think about it. Okay, so let's go for it. Also, it has like things like Barbarian and C++, powerful, something old, or not say legacy, but something ancient. So it had many different connotations, regarding to the meaning, and starting with C and domain available. So it was a no-brainer.
Awesome.
Yeah, it's a great name.
So, Diego, thanks so very much for coming on and talking to us about it. Could you please just run through where people should go if they want to know more about Conan, and like where to find documentation and examples and stuff like that?
Oh, yeah, it's very easy. If you go to conan.io, you will get links to the documentation, to the blog, and also the ways to contact us. We are always very available. We are a Twitter account. We also have a private Slack channel for special cases. And we are also very responsive on email. So it would be very easy. If you go to conan.io, you will be able to go all the way down.
It's perfect. So thank you so much for joining. It was very fun to have this discussion with you, and we will probably continue to have our discussions over text here for quite a while more until this project is done from my side, at least. It was great having you on. I think it was a very interesting discussion today.
Sure. Thanks very much. Actually, I've loved to be here. I feel between friends, and amazed to be also able to speak with Kristoffer. He's an amazing expert. So my pleasure indeed.
Oh, wow. Thank you.
Thank you, everyone, for listening. And next time, we probably speak Swedish again. And we'll hope that, next time Diego is on, he has learned enough Swedish to join us.
Don't bet on it.
No, probably
Swedish
not.
or Spanish. We do either one.
Right, exactly. And have a good week, everyone. And we'll see you next week.
Cheers.
Let me put it this way, Mr. Raymer. The 9000 series is the most reliable computer ever made. No 9000 computer has ever made a mistake or distorted information. We are all, by any practical definition of the words, foolproof and incapable of error.